Hi there, I'm going to show you how to solve a 4x4 Kenken, and if you like Sudoku puzzles, you're going to love this puzzle. So here I've drawn a 4x4. It's 4 squares vertically and 4 squares horizontally. So step 1, for a 4x4 Kenken, write the numbers 1 through 4 across the top. This is going to help because in each row and in each column, you can only have the numbers 1 through 4, no duplicates. If it was a 3x3, you'd write the numbers 1 through 3, and if it was a 5x5, 1 through 5, etc. So for step 2, I like to identify all the single cages as a given. What's a cage, you say? On the diagram, on the drawing, you can see that I've got bold lines and I've also got some thin lines. I also have some numbers with orders of operations and some numbers without. So the bold lines they surround cages. So the first square in the first column, there's a bold line around the square that has a number 3 inside of it. That is a single cage. That's a given. So I'll go ahead and drop my 3 in there. To the right of it, there's a quotient of 2, and there's 2 numbers in this cage. So the thin line indicates that there are 2 numbers, the top square in the second column, the top square in the third column, and that makes up, that equation is going to have 2 numbers. There's the second single cage, and that's the number 2 down in the fourth column, last square. Now I'm going to move on to step 3. This is where it gets fun. Write down all the possible equations to satisfy the sum, difference, product, or quotient answers in each cage. Remember, pay attention to how many numbers each cage requires. So here I've got the quotient of 2, and it can be 4 divided by 2 or 2 divided by 1. The product of 24 has 3 numbers. 4 times 3 times 2 will give us that answer. The difference of 3 can only be 4 minus 1. The sum of 6 is a 3-digit, 3-number equation, so 2 plus 3 plus 1, and then 7, the sum of 7, 4 plus 3. So for step 4, indicate in each square the possible numbers that they can be. So I always start at the top left, but now I have my 3 in that single cage. I'm going to move over to the column number 2, and this can either be 4, 2, or 1. It cannot be 3, but it doesn't require a 3. There's no equation that has a 3 in it that would give us the quotient of 2. So there, I've put my numbers in those 2 squares. Now I'm going to move over to the product of 24. It's 4 times 3 times 2. I cannot have a 3 because there's a 3 in that row. I also cannot have a 2 because there's a 2 in the column, which means I'm going to go ahead and drop my 4 there. And I'm going to also realize that the 2 cannot go underneath it. The 3 must go there, which means the only other number left and the only other square left to give me the product of 24 is 2. I'll go ahead and put that number in there and finish that cage. Then I'll just continue with my difference of 3. I can have a 4 or a 1 in either of those squares in that cage. Then I'll move down to my sum of 6. It can be a 2 or a 1. It cannot be a 3. Then the 1 must go in the bottom square because it cannot be a 2 and it cannot be a 3 because of the row and the columns both already have those. So there's already a 1 in that cage, so I'll get rid of that one and I'll drop my 2 right in there. This cage is easily satisfied. The only number I have left in this equation is a 3. So now I have my second cage completely done. Now I'll move over to my difference of 3, and this can have a 4 or a 1 in it, and so can the square beside it, 4 or a 1. Now the bottom number has to have a 4 here. It cannot have a 3 because there's a 3 in the square above it, which means for the sum of 7, the numbers 4 and 3 go in the squares as I've written them. So now I'm going to take a look at step number 5. Begin to solve each cage or each line horizontally. So now that I have sort of eliminated, and actually I've filled in quite a few squares already, I can go right ahead and I can take a look at which numbers are redundant. So right up in my difference of 3, I notice I still have a 1 there, and I've already have the 1 down in the very bottom square in that column. I'll get rid of that, and I'll drop my 4 in there, which means the second number to satisfy that cage must be a 1. I'll get rid of that 4, and I'll drop my 1 in there, and that completes that row. Now, on the bottom, the difference of 3, there's a 4 in the top column, top square of that column, so I'll get rid of that, and I'll drop my 1 in there. And I'll get rid of my 1 in that cage, and I'll put my 4 in there. Now the very last cage, I know that I can get rid of that too. I can get rid of this 4, and I'll put my 1 in here. And by process of elimination, I know that the only equation that will give me a quotient of 2 is 2 divided by 1. And also, I already have a 4 and a 2, a 4 and a 1 in this row and the column, so I'll drop my 2 there, and that's my last number. I hope you've enjoyed learning how to do a 4x4 Kenken. There are more difficult ones, and there are also more easy ones. So play around with them, have some fun. They're a great way to do some mental math. Thank you.